Hi all, this is the Endocrine Lab. There's not one in your lab manual, so this is another one of the labs that I put in for demonstration, explanation purposes. You will need to understand this material. You'll need to answer some questions about it on the practical and maybe even on the lecture test for the endocrine system. One thing that you can do is download and print out a copy of the Endocrine Lab paperwork that I have online for you, or just write this down. The rest of it is going to be kind of on the computer anyway, and you can look at it as many times as you want. When I do this in the live class, there are two things I do. One thing is I fast the night before the class, and then I take a glucose sample. I do the finger stick the same way I did hematocrit and stuff, except I take the sample and I measure it with a little glucose meter, the same kind people use who have diabetes. And I get a baseline glucose, the baseline glucose, which I got this morning when I did this test after fasting overnight. 96 milligrams per deciliter. Normal is anywhere from about 60 to 100 milligrams per deciliter. Mine used to be a lot lower than that. I'm older and I've especially put on a little weight during COVID, and so my glucose is higher than I would like it to be, but it's still within the normal range. If you get up to 125, that's considered the borderline for diabetes. So you don't want to go over 125 milligrams per deciliter fasting glucose. That means you haven't eaten any glucose recently, any carbs recently. Because when you eat carbs, the carbs go into your bloodstream. Your glucose goes way up. It stimulates your pancreas to make insulin. Insulin then goes to your cell membranes and causes all those glucose transporters to move to the surface and start operating and pull that glucose into your cells, mostly your muscle cells, where it can be used for energy. So in a relatively short amount of time, if you're a healthy person, your glucose levels will start dropping down. So what I did was I took my fasting glucose and then I ate a whole bunch of glucose pills and drank a bottle of Gatorade. The glucose tablets are the same kind you get at the drugstore for somebody who might have diabetes and might go into a diabetic shock or coma or something like that, and every once in a while they might need an extra boost of glucose. So I ate the right amount of that, and on the sheet that I printed out, it gives kind of the limits and the amount that you're supposed to eat and so forth. Then I waited 5 minutes and I took another sample. I took one at 10, 15, 20, 30, 40, 50, 60, and 70 minutes. And I watched what my glucose did. So, big bolus of glucose goes into my blood because I ate it. At 5 minutes, I was still, right around here. It hadn't really started going into my bloodstream yet. It takes a couple of minutes for it to start crossing the intestinal membrane and move into your bloodstream. But at 10 minutes, it had gone up, 15, 20. At 30 minutes after I'd eaten it, I was up to 182. That would be way too high for resting or fasting glucose, but it's fine if you just ate a bunch of glucose. Well, at this point, I'm starting to stimulate my pancreas to make a bunch of insulin. And you can see within just minutes, the insulin starts pushing the glucose out of the blood and back into the skeletal muscle cells, or into the skeletal muscle cells. So that at 50 minutes, 60 minutes, I was getting back down pretty far. At 70 minutes, I was almost down to where I started. If I'd gone a couple more of these tests, I very likely would have gone below my resting glucose because you overshoot a little bit. So I probably went down as low as maybe 85 or something like that. before it balanced back up. But the point of this glucose tolerance test is to demonstrate how quickly the glucose makes it into your blood, how quickly you respond by making insulin to drive it back out of the blood and into the cells where it belongs. Okay, normally that takes the whole lab. While we're doing the other stuff, I keep sticking my finger and writing the numbers up on the board. But here it is. There is my glucose tolerance test for today. And this would show that I'm doing fine. You know, after an hour or so, you're supposed to be below 200. Well, I never even reached 200. So, you know, my response is okay, even though I'm a little bit on the high end of normal at my fasting glucose. All right, so enough of that. Now what we're going to do is we're going to do an online metabolism lab that deals with thyroid hormones. Thyroid hormones, metabolism. Thyroid hormones, metabolism. I mean, there are other things that happen if you're hyperthyroid, but they're mostly related to excessive metabolic rate. Hypothyroidism, your metabolic rate is too low. And we're going to do this with some virtual rats that we're going to test their metabolism. We're going to inject them with a couple of different things. We'll inject them with some thyroid hormone. We'll inject them with TSH, thyroid stimulating hormone, to see what happens. And we'll inject them with a third product which blocks the production of thyroid hormone. So we'll see what happens if you have too much, if you have too little, what it does to the metabolism. Well, here is the opening page here. Metabolism is the total activity of utilization of energy. Anabolism is taking molecules, small molecules, and putting them together in bigger molecules. So you can take glucose and pack it into glycogen molecules inside your cells. You can take proteins and pack them into larger proteins. For instance, if you take anabolic steroids, you wind up making more muscle contractile proteins. You're creating stuff. Catabolism is catabolic, means to break it apart. So you're breaking down proteins, you're breaking down glycogen, you're breaking down glucose because you're exercising, you're using the energy. During the resting period, you go anabolic and pack it back together. Your muscles grow during rest, but during exercise, you're breaking things down. That's catabolism. And that's what we're looking at here, because your metabolic rate is how much you're actually using, you know. And the good thing is that because your ATPs are produced almost entirely aerobically, you can measure your oxygen consumption and use that to calculate your metabolic rate. You know, if you use a liter of oxygen, you burned about 5 calories. That's a metabolic rate. So, those are the things we're going to be looking at. We're looking at thyroxine, which is T4. T4 is thyroxine. Tetraiodothyronine. Okay, so that has 4. Tetra, and triiodothyronine, or T3, is the one that you don't make very much of, but then once the T4 gets inside the cell, you turn a lot of it into T3 because it's way more powerful. So we know about T3. We're talking about that in our lectures. We also know that the pituitary, first of all, the hypothalamus releases thyroid releasing hormone, or thyrotropin releasing hormone, because all the R's, all the releasing hormones, come from the hypothalamus. It causes the pituitary to release thyroid stimulating hormone, or TSH, also called thyrotropin, because tropin means to stimulate stuff. But TSH is the term we're typically going to use. Thyroid stimulating hormone stimulates the thyroid to make more thyroid hormone. And if it's stimulated enough, it makes more cells and your thyroid gets too big, and it's called a goiter. It makes your neck stick out. So it's TSH, the stimulation of the thyroid gland, that can produce a goiter. So we're going to see that happen to a couple of our unfortunate virtual rats that we're dealing with. Okay, thyrotropin releasing hormone, or TRH, from the hypothalamus. TSH then comes from the pituitary, the anterior pituitary. It goes to the thyroid gland. It stimulates the thyroid gland because you have TSH receptors on the thyroid gland, and it makes it make more thyroid hormone. Now we're going to have 3 rats we're looking at. One is a normal rat. He's got all his parts. One is thyroidectomized. That means he's had his thyroid gland removed. Ectomized means like a tonsillectomy is take out your tonsils. Thyroidectomized, that rat has no thyroid gland. The hypophysectomized means they took off the hypophysis or the pituitary. Okay, so the pituitary is missing in this guy. So you have normal, no thyroid, and no pituitary gland. Those are the 3 rats we're going to look at. And here's a kind of a list of all the equipment parts, but I'll describe them as we look at them. Okay, let's see if we can do some of this pre-lab stuff. Which of the following statements about metabolism is false? Anabolism, reactions that build larger, more complex molecules. That's exactly what anabolism is. Catabolism breaks them down. That's obviously true. Energy released in metabolism can be in the form of heat. Absolutely. As a matter of fact, the majority of it is released as heat. All the energy from metabolism ultimately stored in chemical bonds of ATP. No, a lot of it's released as heat. Only about 25% of that metabolic power that you get actually goes into ATP molecules and gives you that energy. Okay. So if we say that one's wrong and check the answer, we'll be right. Okay. What about thyroxine? Is all the triiodine? No, that's T3. It's secreted by the thyrotropin gland. What the heck is that? Most important for maintaining metabolic rate and body temperature. Controlled by T4 secretion. No, it is T4. The most important. That one should be right. Yay. Okay. Thyroid stimulating hormone carried to its target tissue, the hypothalamus. No, it's thyroid stimulating hormone. It stimulates the thyroid. Okay, so that's produced in the pituitary gland. Yeah, that's one of our pituitary hormones. So that's going to be true. An injection of TSH into otherwise normal animal will cause what? What does TSH do? It stimulates the thyroid. So it's either going to make thyroid hormone go up or give you a goiter, make your thyroid grow too big. A decrease? No. Increase of TRH? No, that's in the hypothalamus. Hypothyroidism? No, that's backwards. It's going to make you more and more. Goiter? Yep. TRH is what? Secreted by the hypothalamus. Yeah, all the releasing hormones are secreted by the hypothalamus. Which of the following statements is true? TRH travels the hypothalamus to the thyroid gland. No, it goes to the pituitary and causes the pituitary to release TSH. Hypothalamus primarily propic hormones that stimulate the secretion of other hormones. That's exactly what it does. It releases all of these hormones that go down the pituitary stalk and cause the pituitary to release its hormones. Yep. Yep. Okay, I'm going to submit that because we've got them all right. All right, so here are rats. And by the way, this lab takes quite a while. So if you need to stop and go get a drink and then come back, turn it off and come back on and stuff, you're welcome to do that as many times as you want. We're going to do these rats. Now, the good thing is it moves faster as you get along. After you've done the first couple of rounds, they start doing a lot of the stuff for you, so it moves faster. But we're going to do it ourselves for now. The first part, we're going to do the basal metabolic rate we're going to determine for each rat. Okay, the way we're going to get the basal metabolic rate, and we have to follow the directions here. Click weigh to determine the rat's weight. Okay, we got to put the rat, and here's our rat. We're going to put him in there, and we're going to weigh him. 251 grams. Now, what's important about that is later we're going to need kilograms because his metabolic rate is listed as milliliters of oxygen per kilogram of body weight per hour. That's the way we do it. You know, if I measured my metabolic rate, it wouldn't be just a single number. It would be a certain amount of oxygen consumption per kilogram per minute or per hour, which would allow me to compare myself to somebody smaller or bigger than me. You know, how much is each kilogram using? So 251 grams is 0.251 kilograms. Remember that, because if you start playing with these numbers later after I've, shut up and you're, going back and looking at this, when we do the metabolic rate, it's going to be in kilograms, so it has to be 0.251 kilograms. Okay, so I did that. Next. Click the clamp on the left to close it, so no fresh air can get in and mess things up. Okay. And next, set the timer to 1 minute. And you gotta click on this a whole bunch of times there. Okay. And we're going to start the timer. Now what's going to happen is this rat is going to breathe the oxygen in there. It's going to create a little bit of a vacuum and pull the fluid in this tube to a different level so that you can see how much oxygen disappeared out of that thing. So here I'm going to go start. Fortunately, it doesn't do a whole minute, but you can look and see how as he draws the fluid up here, it goes down here. The difference between those two is going to be how much he used. Okay, good. A minute's already gone. Next. Click the T connector to connect the manometer to the syringe. Yep. Click the clamp there so the rat can start breathing now. Okay. And so now we have this amount here we're going to be able to measure to observe the difference. Now I could look here and kind of guesstimate. It looks like from 7 to 14, that should be around 7 mLs different between 7 and 14. The good thing is I can inject enough to bring it exactly to level. And they make you do it every button one at a time. Let's see, it's going to be about 7. And I'm going to inject that much and see if it brings it exactly to level. If not, I'll adjust it. Oop. It looks like I'm going to need 7.1. Yeah, there we go. So 7.1 milliliters of oxygen was used by said rat in this minute. Okay, now to calculate the per hour, well, if you use 7.1 in a minute, then 60 times that is going to be 60 minutes. That'll be the hourly consumption because it's got to be kilograms per hour. Okay, so 7.1 times 60 equals 426 milliliters of oxygen per hour is the rate at which this rat, what did I say, 426. Next. Now I have to divide it by his body weight enter the metabolic rate. Oh, I have to divide by his body weight in kilograms. Okay, so 426 divided by 0.251 divided by 0.251 equals 1697. 1697 milliliters of oxygen per kilogram of rat per hour. That's my metabolic rate, and it should be normal because, this is a normal rat. Now I'm going to check his thyroid to see if he's got a goiter. Would you expect a normal rat to have a swollen neck from an over large thyroid? Of course not. So I palpate, no remarkable finding. In other words, he doesn't have a goiter. Okay, I'm going to submit that. Now over here, I have to click record data because once I do that, okay, click record data. Why won't it do it? Why won't it do it? Record data. It was working before. To display results in the grid. Okay, so what went wrong here? 1697. Submit the data. Click palpate. I already did that. So it's not letting me record the data. And I think it's because my little screen here is blocking it off. Could I leave that there? Record data. Okay. Good. Now you don't have to write down each number separately because look, his weight was this, milliliter per hour, then divided by his body weight gave 1697. He had no mass. In other words, he didn't have a goiter. And he didn't receive any injection. Drag the rat from the chamber back to its cage. Okay. Restore beneath palpate thyroid in order to restore the apparatus to its initial state. Great. Now I can do the next rat. Let's predict what's going to happen here. What is likely to happen for this next rat? High thyroidectomized rat. BMR will be the same as a normal rat? Well, if he doesn't have a thyroid, he can't make thyroid hormone. What does thyroid hormone do? It raises your metabolic rate. So, no, it's going to be lower, right? If BMR will be higher than the normal rat's BMR, no, he can't make TSH, so he can't stimulate the thyroid to make it. So both of these are backwards. It should be lower. The BMR, both remaining rats, will be lower than the normal rat's BMR. Absolutely, that should be true. Okay, so now I'm going to bring the second rat in, and I'm going to weigh him. Click on the clamp, close it. Okay, next. Set it to a minute. Like I said, they'll do this for you after a little while. And click start. Okay. All right. Click the T connector to open it. Yeah. Click the other one to close it. So the rat can breathe. Yep. Observe the difference. Okay. Let's say it's probably going to be a little bit less. So I'm going to put like 6.5 or something like that. I'll have to adjust it some. But, we predicted that his metabolic rate would be less, so he's going to use less oxygen. See how much this does. How close I am. Oop, too much. Try like 6.2. Whoops. 6.2. Yeah, there we go. So 6.2 mLs. Great. 6.2 times 60. will give us the number of mLs per hour. 6.2 times 60 equals 372. 372. Submit the data. Divided by the body weight of this rat, 245.245 kilograms, divided by 0.245 equals 1518. 1518. Okay. So 1518. Well, we can already tell that's lower than this guy. You know, it's hypothyroidism. Okay. You think this guy's going to have a goiter? No. A goiter is a swollen thyroid. His thyroid's been removed. He can't have a goiter if he doesn't have a thyroid gland to grow. So, no remarkable finding. Cool. Okay. And then move myself out of the way, hit record data, move myself back. Okay. And so we can see lower metabolic rate, lower oxygen consumption, but no goiter because he doesn't have a thyroid. Okay, now we're going to restore. That means clean everything out. Okay, now let's do our third rat. Third rat, we're going to weigh him. Yep. Next, weigh. Yeah, I just did that. Click the clamp. Okay. Go up to a minute. Click start. Now what about this rat? Is he going to be more like this guy or more like this guy? Well, he should be more like this guy, right? Because he can't make thyroid-stimulating hormone to stimulate the thyroid to do its job. So I'm going to do around 6.2 on him as well. Click the T connector. And click this one so the rat can breathe. And I'm going to see if I can go to 6.7. I mean 6.2. Because it'll be somewhere similar. Like I said, this is going to happen automatically pretty soon as we move on to the other thing. Got to go a little higher. Inject. Okay, so 6.3 in this case. Okay, so to connect the manometer to the syringe. Okay. So let's 6.3. Okay, I haven't been following this here. I've been jumping ahead. Okay, so 6.3 times 60. 6.3 times 60 equals 378 this time. 378 milliliters per hour. I'll submit those data divided by the body weight, which is 246, divided by 246, 1536. Actually 1537 because it's 0.58. 1536. Let me do this again. I'm not sure that came out just right. What was that number? The previous number was 6.3 times 60 equals 378 divided by 0.246. 0.246. Got to make sure you do that because it is kilograms. Yeah, here we go. 1537. All right. 1537. Submit the data. Now, is this guy going to have a goiter? Well, what causes goiters? TSH. He doesn't have a pituitary. Remember? He had his thyroid removed. He had his pituitary removed. Can he make TSH? No. So he can't possibly cause a goiter because he doesn't have any TSH to cause it. So we palpate it. Again, there's no goiter on this guy. And I'm going to record the data. Okay. Next. Drag the rat back and hit restore. Okay. Next. Okay. Think, a stop and think question. The normal rat is what? Hypothyroid, hyperthyroid, or euthyroid? EU always means good. Okay? Eustress is good stress, like the kind you get from exercise, as opposed to the bad kind of stress. So U means proper. So the normal rat should be euthyroid. Yep, we're right. Next. The hypothyroid ectomized rat is got to be hypothyroid. You can look right here and see it's low. Okay, so it's hypothyroid. Okay, the thyroid ectomized rat is hypothyroid, correct. And the hypophyxemized is also, right, because they're both low. Doesn't have the ability to stimulate the thyroid. Okay, good. Now, prediction. Normal rat will become hyperthyroid. What do you think will happen if you inject thyroxine into the 3 rats? We're going to give them each a thyroid hormone shot. Okay, thyroxine. There's our needle. We're going to give each rat a thyroid hormone shot. What's going to happen? Will the normal rat become hyperthyroid and develop a goiter? Well, he's going to become hyperthyroid because he has too much thyroid hormone. But will he develop a goiter? No. What gives the goiters? TSH, 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 thyroid stimulating hormone. So that one's not right. Thyroid ectomized rat will become hyperthyroid and develop a goiter. Well, he can't develop a goiter. He doesn't have a thyroid. Okay? He can become hyperthyroid because you give him too much thyroid hormone, but he can't develop a goiter because he doesn't have a thyroid gland. Hypothyroid will become hyperthyroid and develop a goiter. Again, you don't develop a goiter with extra thyroid hormone. It's TSH. It's TSH. The normal rat will become hyperthyroid but will not develop a goiter. That's got to be the correct answer. Next. Now we'll use the same procedure. We're going to drag the rat into the chamber, click the clamp on the left, set it to start, and then you're going to, for this part, follow the same procedure. Drag the rat in and weigh, and then all of that kind of stuff, all right? But we have to inject the rat with thyroxine, right? Okay, and then we're going to drag him in here, and we're going to click weigh, and we're going to do that, and we're going to add, do this for a minute, start. Okay, and we're going to inject. Now, what do you think this rat's going to be? He's going to be hyperthyroid, right? So it's going to be higher than 7. let's see how much higher he is. Oh, wow, a lot more. Wow, 8.5. Okay, 8.5 times 60. 8.5 times 60 equals 510. 510. Divided by 0.251. 2032. 2032. Record data. Oh, palpate. Is he going to have a goiter? No, he got thyroid hormone, not TSH. Nope, nobody's got a goiter yet. Record the data. Okay, next. Take the rat back. Clean, that doesn't mean they're cleaning the cage. It means they're cleaning his bloodstream of the thyroxine so you can do it again later. Okay, well now let's give the thyroxine to this guy. Put him in the chamber. Let's weigh him. 245. Okay, let's set the timer to a minute. Start it. Okay. Now, is this guy going to be hyperthyroid? Well, you gave him a shot of thyroxine. He's probably going to be a little high. It depends on how much you gave him. They don't tell you how much they gave, but we're going to say he's going to be a little bit hyperthyroid. Not as much as the guy that already started out with plenty of thyroid and got more, but let's see. Let's try 7.5, something like that. See if that's about where he is. Inject. Oops. Sorry, I have to do that. There we go. So yes, he's hyperthyroid too. Look how much higher that is than the original number. But it's not as high as the guy that started out with plenty of thyroid and got more. Okay, so we're going to go here. Oops. Back. Oh, palpate thyroid. Is this the right one? 7.8. 7.8 times 60 equals 7.8 times 60 equals 468. 468. Submit data. Okay, this isn't working right. Metabolic rate. 468 divided by 0.245. 468 divided by 0.245 equals 1910. 1910. submit data, and it's still higher than the normal rat, but not as high as this. I mean, higher than the original rat. He's still hyperthyroid a little bit, but not compared to. No remarkable finding. He doesn't have okay, so there's our 1910. So there's that rat. Okay, so here we go. Drag the rat back. Clean his system. Give this rat a shot. Ratatouille. Drag him over here. Weigh him. Close that clamp. Start. Okay. Now, what's going to happen with this guy? He should also be a little hyperthyroid. He doesn't have a pituitary, so he didn't have much thyroid hormone to start with, so he shouldn't be too different from that thyroidectomized rat. Let's go up here somewhere, 7.7. Let's try that. At least he had a thyroid gland to begin with. Just was missing his pituitary. There we go, 7.9. 7.9 times 60 equals 474. 474. Submit. Here we go. Divided by 0.246 equals 1927. 1927. So you see he's fairly close to your rat that's missing his thyroid. Will he have a goiter? No, he's not making any TSH. It's TSH that causes goiters. Great. Submit. Record data. Okay, so let's get this guy back out of here. Clean him up. Okay, so now we're going to start with the next one. What's going to happen when we inject TSH in a rat? All the same procedure, click and all that, So we're gonna inject TSH in this rat. Drag him to the chamber and weigh him. We're gonna do this, and we're gonna that. What do you think is going to happen with this rat when we inject him with TSH? Well, he should become hyperthyroid, right? Because he's got a thyroid gland. TSH stimulates the thyroid. So it should go up a little bit higher than it was before. So let's go up to 8. And he'll probably develop a goiter, right? TSH causes goiters. So he's already got the right amount of TSH because he's a normal rat. Now we've given him more. So presumably, he's going to be a little bit hyperthyroid, and he will produce a goiter by having the extra TSH. Oops, a little bit too high. Okay, 8.0. 8 times 6 is 480. 480 divided by 251. 480 divided by 0.251 equals 1912. 1912. So that's a little hyperthyroid. That's higher than he started out with. Okay, submit the data. Is he going to have a mass? I bet he does. Yes, mass found upon palpation. He has a goiter. Record data. Okay, did we get him on here? Down here? Yep, he's the first one that has a mass. Okay, so far it's not doing its auto thing for me, but you know, we're moving along pretty fast now. Let's clean him out. Let's give a TSH shot to this rat. And then we're going to put him in there. And we're going to weigh him. And then we're going to close that. And we're going to add some. Start. Now this guy is getting a TSH shot. How is it going to affect him? He doesn't have a thyroid. Nothing should happen to him. Okay? He should stay hypothyroid. TSH can't affect him because it stimulates the thyroid gland. Well, he doesn't have a thyroid gland. So he should still be a little hypothyroid. Be a little low, I think. I think he's still going to be hypothyroid because he doesn't have a thyroid gland and TSH isn't going to have any effect on him. Oop, even lower. Oops. There we go. 6.4. 6.4 times 60 equals 384. 384. It didn't let me write it down. 384. 384 divided by 0.245. 0.245 equals 1567. So he's still 1567. Submit data. Okay, is he going to have a goiter? No, he doesn't have a thyroid gland. He can't have a goiter if he doesn't have a thyroid gland. Palpate thyroid, no mass, submit, record data. Drag him back. Okay, clean his cage. Let's do this one, and this is going to be the last rat we'll do. There's three more under the next protocol, But I'll just tell you what happens because it's not doing this faster automatic thing, and this is taking a while. But I'll tell you, we'll discuss, and I'll tell you what's going to happen with these other rats. So I'm going to weigh him, 0.246 kilograms, or 246. Let's close that. Let's let him breathe for a minute. Good. Okay, and I'm gonna, now what do we think is going to happen with this guy who's injected with TSH? Well, his thyroid hormone should go up, right? He still has his thyroid gland, he just doesn't have any TSH to stimulate it. So he should have a pretty decent metabolic rate now that he has TSH. In fact, it may be a little hyperthyroid if you gave him a big shot. I think with this program, what they're doing is giving him a big shot of stuff to kind of show what would really happen. So let's go up a little bit and see what happens here. Whoa, that went way high. Yeah, this is actually bringing him back to a more normal. Huh. Okay. So if he got a shot of TSH and he didn't have a pituitary, he should have come up with a relatively normal metabolic rate. Seems a little low to me, but let's see how that works. No, I didn't do that. I wonder if that had anything to do with it. Okay, on this guy we have 6.3 times 60 equals 378. 378 divided by 0.246 equals 1536. 1536. Will he have a goiter? Well, he has a thyroid. If you gave him enough TSH, he might have a goiter. Let's see. No remarkable finding. Okay, so you gave him just the right amount. Looks like they gave him just the right amount. Okay, and then I'm going to bring him back, and I'm going to clean his cage. Clean him. Should have hit done. If he's still there, I should have done record data. Okay, that's fine. Okay. So what I want you to do is be able to look at these, because on the test, you're likely to have a question like, if you took a normal rat and injected them with TSH, what would happen? They'd become hyperthyroid and get a goiter, because TSH causes goiters, but it also stimulates your thyroid. If they got a shot of T4, thyroxine, what would happen? They'd become hyperthyroid, but they wouldn't get a goiter, because TSH is what causes goiters. If you take a thyroid gland out of a rat, it can't get a goiter. It's going to be hypothyroid, but it can't get a goiter because a goiter is a swollen thyroid. If you take the pituitary out, they can't make TSH, so they're going to be hypothyroid. But if you give them a TSH shot, they should go up to normal thyroid levels. And this last one didn't turn out exactly the way that I had predicted, but that's okay too. You can look at these numbers here. Okay, if you want to like take a picture with your cell phone or something, you can look at those and see what's going on. There's 3 that got thyroxine, and then there's 1, 2. Oh, that's this last one. It didn't record him. Okay, that's okay. But you can see that the mass happened to the one that got TSH. Okay, except if he didn't have a thyroid hormone, a thyroid gland, he couldn't get a goiter because he didn't have the gland. So if I took this out to the rest of its conclusion, what we would do is I would give everybody a shot of this propylpolyuracil, okay? What it does is it blocks you from making thyroid hormones, okay? Blocks you from making thyroid hormone. So let's just talk through what's going to happen. You give this guy something that blocks thyroid hormone. Well, he's going to become hypothyroid, right? He's going to become hypothyroid if you block his ability to make thyroid hormone. What's going to happen to TSH? Because thyroid hormone is the negative feedback for TSH, TSH is now going to go up. There's no thyroid hormone to block TSH production, so TSH will go higher and higher and higher, trying to get the thyroid gland to work more. It's like having an iodine deficiency. If your thyroid hormone drops, TSH goes through the roof, trying to make more thyroid hormone. TSH causes goiters, right? So this guy is going to be hypothyroid, just like he has an iodine deficiency. You blocked his thyroid, but he's going to grow a goiter in his neck because his TSH is going to go way up, trying to make enough thyroid hormone. What if you give the same thyroid hormone blocker to this guy? He's not making any thyroid hormone. He doesn't have a thyroid gland. Nothing's going to happen, okay? Because he's already hypothyroid. He's already making 0 thyroid hormone. So now he's still going to make 0 thyroid hormone. So you won't see a change in him. And the low thyroid will make him make more TSH. So what? He can't grow a goiter. Goiter because he doesn't have a thyroid gland. Okay? What about this guy? He doesn't have a pituitary. But he does have a thyroid gland. It's probably not working much because he doesn't have a pituitary to cause TSH production. So if you give him a thyroid blocker, his metabolic rate will drop a little bit because the thyroid gland, if it was making any at all, it can't make it now. He can't make TSH because he doesn't have a pituitary. So he won't make a goiter because he can't make TSH. TSH causes goiters. TSH causes goiters. TSH causes goiters. So you block his thyroid hormone, he's going to become hypothyroid and get a goiter because the TSH will be trying so hard. Give him a thyroid blocker. He's already hypothyroid. He'll just stay that way because he can't make any. And he can't get a goiter because he doesn't have a thyroid gland. Give this a thyroid hormone blocker. His thyroid hormone will go down a little bit. But he's not making much to begin with because he doesn't have a pituitary. He can't make TSH, so he won't get a goiter. TSH causes goiters. TSH causes goiters. TSH causes goiters. Stop and think question. Okay, let's look at these. We'll go through these really quick. A normal rat is, you thought, oh, we already did those. We did those. Yeah, we did those. Judging the basal metabolic rate. No, we did that one. The normal rat. Which of the rats developed a goiter after injection of thyroxine? None of them. Thyroxine doesn't cause goiters. None of the rats developed a goiter because it's TSH. See? What do you think will happen after you inject TSH into the 3 rats? Normal rat will become hyperthyroid and develop a goiter. Yeah, TSH, yes, because TSH stimulates the thyroid and causes goiters. Yep. Yep. Okay. Next. Let's see if we can get past all of this stuff. Okay, forget that. Let's go to submit. Let's just submit everything. Have you completed the entire, as much as we're gonna? Okay, now here's some other questions that can come along with this. How will you treat a thyroidectomized animal so it functions like a normal animal? It can't make thyroid hormones, so you better give it thyroid hormone. No TRH isn't going to help, okay? TRH would stimulate more TSH production, but TSH only causes the thyroid to work. And if you don't have a thyroid gland, you better give him T4 supplements. Iodine tyrosine supplements won't do any good. Those would allow his thyroid to make more thyroid hormone, but he doesn't have a thyroid. Rest of the missing hormones in the rat without the pituitary. What would some expected symptoms? Unexplained weight loss, hyperactivity, high body temperature, decreased metabolic rate. Well, unexplained weight loss could be it. He wouldn't have any growth hormone, right? Decreased basal metabolic rate. Well, certainly decreased basal metabolic rate. I guess we're just talking about thyroid hormone here. So decreased basal metabolic rate, of course. An injection of thyroxine in otherwise normal rat would cause hyperthyroidism. It'll suppress these guys because these negative feedback is T4. And you're not going to get a goiter because TSH causes goiters. Why didn't any of the rats develop a goiter after thyroxine? Because thyroxine doesn't cause goiters. Negative feedback mechanisms were impaired. In all cases, TSH levels were not elevated. Okay, and TSH is what causes goiters. Why did the normal rat develop a palpable goiter with the TSH? Because TSH are overstimulated. Okay, you overstimulated the TSH receptors on the not on the hypothalamus. TSH receptors on the thyroid gland. See, I almost got that wrong by going too fast. An injection of the thyroid hormone blocker to an otherwise normal animal will cause goiter development. If your T4 drops down too much, you make more TSH to try to compensate. So you get a goiter. Okay? That's probably enough of these. That should give you a good idea of what's going on. You'll have a couple of questions like these on your test, and perhaps on the certainly on the lab practical, maybe on the written test too, about what would happen if, what would cause you to develop a goiter, TSH, anything that causes TSH to go up. And you have to have a thyroid gland to get a goiter. Maybe what kind of treatment would you think would be best if your person had lost their thyroid gland? My wife had an antique shop for a while and had a woman working for her whose thyroid was completely removed because of thyroid cancer. And she had to take thyroid hormone supplements all the time. It was tough because your thyroid keeps it really, really, really normalized all the time. And she she would drop down, and then she'd take it and it would go up, and she'd drop down and she'd take it and it would go up. And she said it wasn't really very much fun having that situation. Okay, that's enough of this. I hope that helped elucidate some things and didn't confuse you. It's a lot of fun when everybody's around the room with a bunch of computers doing these labs together and talking about them. But I think this probably did a decent job for you.